Hello. So I'm dialing in instead of the west side of the world where Louis was from. I'm dialing in from Europe, Belgium. So my name is Sam. I'm an Azure MVP, and I work at different startups right now. And I'm going to explain today on how I did my journey from my, let's say, 20 plus years of backend experience all the way to become a full stack engineer. So I'm a Microsoft MVP, and as I said, I work with startups, and there I'm advisor or investor. Currently, I'm working at Sphinx, which is an access control platform where we give digital keys to physical locations. And we want to centralize those things. My focus has always been on data, on AI, and serverless applications using Microsoft Azure. And next to that, I have a passion for cycling and traveling. So how did I end up in becoming, a full stack one? So I started my career with BizTalk, actually, at a development shop. Then I joined an industry company where I did a full project as a lead of the BizTalk thing. So BizTalk is an integration in the middleware. And then I joined at that moment a one-person company, which is called Coded. We worked with several people from India at the same time as well. And I got myself to become one of the co-founders, so becoming a shareholder. I became CTO. I focused on product development, and then we got acquired by a big company. And I was, after that period, leaving Coded because I said I want to do something new again. I want to build something from scratch. And that's where I started working with startups. I became a tech advisor at an AI company in Belgium, which is Human. And then I became co-founder, tech lead, and advisor at Sphinx, which is the company I'm working on right now. And as you can see, I started with backend, but I ended up becoming a full stack engineer. So we are working at Sphinx. As I said, we have built apps. So an app that can be used for home service providers. So that could be people taking care of your elderly family, for example, and they have to enter the house in a secure way by opening locks. So we integrate with smart locks, but we built the software, the middleware. And what we actually do is we give on the left side access to those people to physical locations. And those locations could be parking garage, it could be your smart postal box, it could be, of course, the door of your front door of your home. And we are in the middle. We are building that platform. The team that we have is looking like this. So we have on the business side, we have our CEO, business lead, marketing manager, and so on. And on the left side, we have the CTO, technical lead, test engineer, DevOps person, and so on and so on. So I'll put some names to each one of these roles. And actually, and that's the whole point, we are just two people. In our company at this moment, it's a startup. We are two people, that's all. We have Matthijs, which is the business lead, and you have myself, which is doing the tech side. So you can see and you can understand that if you work with a startup, you have to do many things. You cannot just focus on one thing because you don't have the resources, you don't have the big team, right? And that's the whole point. And I've learned some things with working with startups that are different from working with, let's say, the industry and the manufacturing companies that I used to work with. So what is important, if you deliver software, especially if you don't have a big team and a big amount of money, then you have to make it work as soon as possible. You have to make sure that you get feedback from customers. So you get something out, you make sure that you get it right after that. And if you see that we have built the right functionality, then you can focus on optimizing and making it fast and reliable and all these things. That's an important one. And actually, I have a presentation that I sometimes give also on, let's say, lessons that I learned from working with a startup. And this is probably the most important one. The use of technical debt. I used to work with large industry, large insurance companies, and this is how they delivered value. So the features they built, they were quite small, short, the number of features they have to build, because it takes a lot of time and they make sure that everything works for, let's say, millions of users, and we have to make sure that it's reliable. And if this zone in Azure fails, then we have to fall back to another zone and all these things, and it costs so much amount of money. And that's what I call over-engineering, because we had a customer that was spending up to 100,000 euros per month just on Microsoft Azure. And the reality was that he only had 400 users. So the cost per user was tremendous because they were over-engineering everything for a potential future. But they found out that the platform they built, the functionality, was not necessarily the one that the customers wanted. And this is how it typically works with a startup. You quickly release something. It's like, it's the code that you don't want to show to other people, but at least it works. You show the idea, the concept, and then of course you get some validation. You see, oh, we have to tweak this and this. And then you have to make sure that you have some cleanup every now and then. And then you say, okay, we have a new big release and so on. So that's more the healthy philosophy of releasing software at startups. Okay. Now, switching to technology, because I've set the scene. I think the most important thing is working at a startup is totally different. And for me, it was a big journey because this is the platform that we built. So everything in the green box is, let's say, the Microsoft Azure platform. So we have an adaptive framework, we have an API, we use Microsoft Azure Active Directory B2C, which is now Entra being called. We use API management, service bus, all those typical things using Microsoft Azure platform as a service. And that's my bread and butter. That's what I've been doing for the 20 years. But suddenly, we had to make sure that the customers using the platform, they were having a front end. And these things, an app, either on Apple or on Android, and a web front end, these things were quite new to me. So I had to make sure that on the web portal, we had a management portal for people. We had to make an end user portal and so on and so on for people using the web and the browser. And at the same time, we were having an app, and the app is being used to open my door, for example, at home, or it's used by other people delivering services to my place. And I had never built an app. I had never built a real web portal that was intended for more than just a report thing. So I had to find something that I said, okay, there's a lot of common logic that I use in the app and I use in the portal itself. I want to use the same style, of course, because you have some branding that we have built, the same colors, the same fonts and so on. And I wanted to, for me, to have the smallest steep learning curve because there were so many other things I had to worry about with the startup. So it had to be a lowest barrier to entry. And with that, and that's the whole point of this session, I found out that for me, being a backend Microsoft C# person, switching to something that was called .NET Blazor and .NET MAUI was for me the right solution. And I can already say something important. This, or my takeaway for this session, is not at all that these technologies should be the technologies that you use if you want to build an app. I'm saying that those technologies really helped people that have the experience with programming and backend logic, and that suddenly have to build an app. This was the lowest barrier to entry, and that's what I want to give today. So starting with Blazor, what you have Blazor Server and you have Blazor WebAssembly. What is important, and I've used Server, by the way, because you have less and less JavaScript linked in the Blazor Server, and you actually use SignalR over WebSockets. So all the logic, the handling of your events and so on, all of that is actually done on your server resource. And it's synchronized using WebSockets and SignalR. So that's an important one that you give. And you actually keep the browser connected with your server resource, which is called a circuit. And that circuit is keeping the state of your session on the server in the cloud or on the backend. So the advantages of server is really that you have a small download because all the logic remains on the server. So it's faster loading. The downside, you could say, is that you have a higher latency because you have, for every action that happens, you have a round trip. It works very fast, but still that's the case. WebAssembly is something different. You run your application in the browser, and that whole WebAssembly is being downloaded and executed locally. So it's a heavier download, which means it could take a bit longer the first time you load. But the good thing is that it's lower latency. You typically have more JavaScript interaction than you would on Blazor Server. So I picked the Blazor Server thing. And one thing I want to give as an extra takeaway is that I found out that having a lot of components, I had to build nice looking text boxes. I wanted to have check boxes, you know, all those type of things. I found out that Blazor was one that was really helping me. It's a free library, open source, good support, good examples, good documentation. You also have another one that is quite similar, and I just picked, I worked with the two, and I seem to prefer Blazor, but you also have MAT Blazor, so M-A-T, which is quite similar. And they are based on material design. So material design is like something that I think from Google was, you know, documented to say, okay, we should have a consistent look for apps and applications on the web. We want to make sure that we have, let's say, the same types of, for example, controls like the ones you see on the top. So all these controls have been built by Blazor, and you can just drag and use them in your application. And one of the things that is nice as well is that you can define your themes. So as I said, we want to have the same look and feel. Well, we said, okay, the default theme is this type of font. We want to have this color. We want to have the spacing between the letters and so on. All of that can be defined in your theme. The same thing with your colors and so on. And you can do that, of course, in CSS, which is style sheets, but you could also just do that in C#, which is, again, for me, quite easy to use. And one of the most important things, and I will show that in a demo, is the concept of grid. So you may know the concept of responsive web design or web applications, where the web application might look different if you open it on a mobile phone versus on this laptop. And for that, you have different screen sizes that you can just get out of the box. You don't have to build and calculate different things. So what you can say is that if my application, for example, is running on a small screen, then I will make sure that the menu is, for example, hidden and things like that. So that's quite an interesting, to build a responsive design. The grid is a component in the material design that really helps in styling these things. And I think I will, what I want to give first is that you have to, for the concept of grid, you have to visualize for yourself that the grid itself is like a virtual split up of 12 different columns on your screen. So it's like virtual 12 columns that you want to give content to. And I will show that in the demo, as you can see. So I will show in the next demo how you can quickly build a Blazor web application, and how I have used Blazor for that responsive grid and that look and feel. So let's switch to Rider, which is the IDE that I happen to use. And if I just want to create a new web application, I can just say, okay, I'll create a new project. I will create a Blazor web app. I give it a name of Azure, NET Conf. And you can then specify, is it a web app or so the server app, or is it the web assembly? And you can specify if you want to use Docker and things like that. So just creating it takes just a few seconds. And if you just want to run the application, as you obviously could guess, it opens in the web application and you get a standard layout, which the first time always takes a bit longer, but this is the Hello World application. Now, let's stop this one. And I have built another application, of course, my custom application, to explain some things. So the application itself is here in the picture app.online, and it consists of different pages. So you will see that I have, for example, the homepage, which is index. Here I can specify different things like welcome to my Blazor web app. Let's call it picture app, and you will see it will automatically change things. What you can also see is that I have here two different components. These components are components that I have built, and if I click on them, you can see what happens. I just want to make sure that I have injected different dependencies, which is in this case, inject the I options. So if you are familiar with ASP.NET Web Core, you can just use those options to configure your application. As you can see here, I have app settings. and I have a Google app API key that you should not copy right now. And that app API key is being injected here by saying, okay, I want to have this object, Google search config with an API key and an engine ID, and I'm injecting that here from that section that I have shown. So in this way, every component that I have can access that specific configuration. And if you're familiar with dependency injection, you will see that I have, for example, also injected picture service, which is actually nothing more than a Google query to search on specific images. And the images, the search itself is this string. So I can say pick pictures and how many pictures do I want to have. This is a service that I have just injected and I can use in my component. So let's go to the component here, for example, where I want to show the image result. And here you can specify, okay, I'm having a picture and that picture is a parameter on this component. And I can just say, okay, I'm now using the pic here to use the image URL, description, and so on. But you can see that I'm also here using the MUD components, so which is quite powerful. I also have then the page to show my picture album, where I have that MUD grid, and that's what I will show. And this MUD grid has, for example, a text of H1, which is header 1, of course. And I have, again, this component, the dynamic screen visualizer. And if I have pictures loaded, and as you can see here, the pictures have been injected, so that picture service is injected. And here I'm just saying, okay, pick my pictures using that term that I give. Or if there's no term, let's just take pictures of bikepacking, and let's take 8 pictures. And that's what I do. So I load that in the variable, which is just a list of pictures. And pictures is the objects that I use, of course. And I'm then iterating through that picture list and specifying the MUD item here. And I will show what this specific is doing here. Maybe zoom a bit, but you can see that I have XS, SM, and so on. And I will explain that when you see the application. So this is my application that is running. As you can see, I changed from Blazor web app, I changed to picture app. And you can see here, I have this component, screen details. That's the dynamic screen visualizer that I have just created. And what I'm doing, I'm actually specifying this screen that I'm currently using. The size of the screen is LG, which is large. It's like the clothing sizes. And you can also get the actual width and height. Now, if I just change the size here, you can see that it now becomes medium. And if I change the size again, it becomes a small. And if I change it again, it becomes an extra small. And what you may have seen is that the difference between extra small and small was that my menu on the left side was disappearing with the extra small. I'm now making it small, and you see the menu is coming back. For that, I did not have to write anything specific. This is the way that responsive design works, and it's fully embedded in those components of MUD Blazor. So if I now go, for example, to my picture album, you can see I have now pictures of bikepacking, and I'm currently in a large. So the large mode, you can see I have 4 columns showing the bikes. If I again open it in a different screen size, you see this is medium and I only have 3 columns. And if I go smaller again, then you can see I have 2 columns. And if I again get smaller, suddenly it becomes an extra small and I only have 1 column and the menu disappears. And this is something that I learned and I found very powerful. So how do I specify that I have these 4 columns, 3 columns, and so on? That's exactly by these things here. Let's go back to my picture album. So I said for every picture that I have loaded, I will create a MUD item, and the MUD item is just a child element of MUD grid. And I specify that if the screen is an extra small, then the width the dimension of the image result, this specific image that you see, that should be 12. And 12 is actually the virtual size of a screen. Regardless of the size, they say 12 is the maximum. If the screen is small, I'm saying, oh, let's take 6. And 6 is, of course, the half of 12. So that means I would have 2 columns because they only take a virtual width of 6 in a total size of 12. And with a medium, they take 4, right? And 4 is 3 columns. And if I take a 3, that means it's 4 columns because 3 is 1/4 of these things. If I, for example, change medium now to 12, which is ridiculous, but just to explain how things work, you can see with medium, now I have, because I set the size of 12, it takes the full virtual 12 width size. And if I become small, the screen, you can see it becomes 2 again. So that's the way that you can really play with those things. And that's, in my opinion, something that was very powerful. So this is the way that I was building components and applications. So let's show how a page typically works. A page is actually having this attribute here, page, and it has the route. So the routing here is if I navigate to pics from pictures, then this page will be found and linked to. I also say that I can navigate to pics passing an extra path parameter, which is search term. And what you will now see, I have also declared search term here as a parameter. So that means I can also query this page, and instead of having nothing, I can add something, and that will be my search term. And on the initialization of the page, I'm using this value, search term here. And if the value is being passed, I will call that picture service using that term. If it's not, then I will default to bikepacking. So we should be able to explain that and to show that if I say, let's call it curry bowl, because we are India. And you can, of course, see here that some pictures have been taken using that specific value. If I say, no, I'm more of a pizza person, let's click here, and we can see different pizzas. So I'm just querying Google with that value that I have passed here in the query parameter. So that's the way that pages typically work here. All right? Then the component, that's the important one. So I said here in picture album, for every picture, I want to have image result, and I'm passing in a parameter. Well, that's exactly what you have seen here. The component is just another razor component, and it has another parameter of type picture. And here I specified, oh, let's use a mud card, which is again a material design component. I'm using a media of that URL. Then I want to add some text of the description and the file type and so on. And I want to have some actions. And that's exactly what you have seen here. This is the image media. You see the website it comes from, the description, is it a JPEG or a PNG and things like that. And you can have some actions. So all this layout and things are being done by those components, by Blazor. And I had to write 0 JavaScript, 0 CSS. The only things that I had to do was some markups. So combining HTML and the components of Blazor and not Blazor. And all the rest was just C#, and that's the language that I have been using for ages. All right. So switching back, the other thing that I had to do, because I started with a web application and we said, okay, we will find out, we may be hiring an application developer, but then we saw, okay, we don't find the right money, so let's also make the app ourselves and we will find out so that we at least have an app to use and we can always find something later. So the reality was, okay, this app has become a real app that we have been using for a while and that you can now download from the different portals. So the Google Play and the Android store, right? And this is, at this moment, the app that is running. You can download it from the application. And I have built it with .NET MAUI. So .NET MAUI is the interesting one because for me, again, it was nice. I could use the same programming experiences that I had. And I could also build, let's say, one code base that was running for all these different things. And the most important one for me were iOS and Android. So I had a single code base, and actually it's an evolution of Xamarin, but I had never used Xamarin in my life before. I have to be honest, it's quite a bit of pain. In the session of Louis that we've seen, you can see that it has become significantly better with .NET MAUI 8. I started with 6 back in those days. So you have to, install extra code for iOS. You have to install Android Studio. So there's quite some dependencies, things that are quite new for people that are just backend persons like me. Then publishing things, for example, to iOS were also quite cumbersome. I had to register and pay for a developer account. What I remember was that for every screen size, so an iPad, an iPhone 13, 15 Pro, and so on, I had to make screenshots because they had to be uploaded in the App Store. So that was quite cumbersome as well. And then, of course, they are quite strict, which is not bad, of course, on privacy policy, terms and conditions, and so on. Another thing that I remember is that we had to make a test account and provide the password and the username to the people of iOS that validate your app. And they are actually logging in your application and see if things work. So this is also quite intensive. Once it's deployed, then it gets easier to have new releases coming up. Now, if you would look at Blazor, and you have seen it in at .NET MAUI, you may have seen it in the previous session as well. The reflex, if you're totally new, would be, okay, let's learn XAML. So XAML is the markup language that is being used for building these applications. You can do that. My intention was, oh, now I have invested quite a bit of amount of time in learning Blazor. So I said, I see that .NET MAUI is having support for Blazor. And I said, okay, let's use that. I want to use my Blazor experience that I just acquainted. I want to use it for .NET MAUI. So I could start looking at reusing my components. So the components that I had built for my application to open a lock and so on, or in the sample application, my picture album and so on, I want to reuse those same components both on the web and in my application, in my mobile app. And the good thing is, since I was using Blazor, I could also use the components of MudBlazor or MadBlazor or virtually any other Blazor library in that application as well. So that was quite interesting. If you want to do that, how you do that? Well, you create a new application, Razor class library, which is sometimes referred as an RCL. So it's a shared library that can be used by different applications. And an important one is that you can even share pages. So the page of picture album in my demo is part of my shared library project. And that page is being found both in my .NET MAUI and in my web application. And I had to do something here to say to route. So remember that I had /pix/pizza, for example. That routing, I have to indicate, don't only search for pages in the specific library of my startup application, but also search in additional assemblies. And this is, for example, the assembly of my shared library. I said the about page is there, and that's how they find these locations there. Okay. What you can also do is you can share different things. You can share links, references, media, images, and so on. And if you want to link to something, for example, here I have a style sheet that I said, okay, this style sheet is actually referenced in my shared project. I just have to do _content/ and then the full qualified name of my project. And it's the same thing with an image. Here I have an image that I said, okay, the logo that we have, full stack logo, for example, that logo, I want to just have it once in my shared library and I want to reference it from the other things. That's how you do it again. Content, fully qualified name, and then images and so on. All right. So let's show you how I have built that same picture app now in a mobile app, right? And that's the thing that I want to show here. So this application the picture app that is running in Blazor, I can now also start it from .NET MAUI. So again, the same thing. To build an application, you just say new project. Here you can search for MAUI if the template is being installed. Sorry. And here you can specify, is it a MAUI app, which is more like a native app, or do you want to make it a Blazor app or even a Blazor hybrid app? So I had to do this, create my application, and you just can get started. So that's what I did here. What is interesting is that all the code that you can see here, all that specific code is shared. And it will be compiled at compilation time, of course, for iOS, Android, or the compilation of your choice. The specifics, they are part of platforms here. So here I have specific things. For example, for iOS, you have to specify different properties. It's like a manifest. And you can also specify for Android that you have an application and you can have some things that you overrule, things like deep linking and so on, typically works and can be specified there. So that's an important one. You have some specific things, but most of the items are, let's say, shared. What you can also do is, if you have a component and there is something that you want to tweak, for example, in my component, shared here, imagine that this specific section only should be visible in iOS for whatever the reason, then you typically use these pre-compilers. So I can specify if iOS, and if I think it's something like that, and everything in between here will only be compiled and included if I'm building for iOS. So that's the important thing to keep in mind. All right. So other than that, since I have specified that I'm using Blazor in MAUI, I have the same pieces of logic. So I have my main page here. I have, like you can see, the router. And what I've done here is I have added additional assemblies so that it searches also in, and there I specified the about, which is the about page here. And that's part of my shared project. So the shared project is here on the left. And as you can see, I have my components there. I have my pages here. I have some, I'm searching for, different objects and so on that I can share between the different items. I could even include images and everything that you want to see there. All right. So my .NET MAUI application here just has this home page. Welcome to your new, let's call it iOS, MAUI app. And if I just click run, so what you can specify here is I have .NET MAUI that I want to run. And here you can specify I should run it on what type of application. So you can see this is the Android guy. I will run it on iOS. So I'm picking the Apple icon there. And here I can specify all the different simulators that I have. Right? So you can just run this on your laptop and just have a virtual emulator. If you would have your Apple device, so your physical device or an iPad, you can also connect it that you can see it here. I'm someone that works, I think, 7 years by now on Mac. If you would be a Windows developer, you typically have to have a physical app device. It could be a small, cheap type of iPad mini or something, and you have to configure it. I never had to do it because I'm native on Mac, but it's something that you have to keep in mind if you want to build applications for that. So here I can specify I want to run on different emulators. In this case, I have just picked iPhone 14. So running here, again, takes a bit of time, especially in the beginning. And this is my iPhone 14 emulator. And you will see that this is the application that now gets started. And you can see MAUI rocks, welcome to your new app, and so on. You can see the same exact components that I've used. This is the extra small size. So that's an important one. Remember the responsive design that I talked about. So extra small is the default size screen of this one. And let's go here in navigation to the pictures album, and you should see, because it's extra small. Remember that I just had one column, so I if the screen is extra small, the width of that column should be 12, which is the full size there. But for example, if I turn the layout or the orientation of my iPhone, which I can do virtually, then you can see, oh, it becomes a small and no longer an extra small. And by the way, I was opening the previous application because now you can see MAUI. So that's how long it sometimes takes, especially the first time. So let's go back here, but you can see I have 2 columns instead of that 1 column because I have turned the orientation. All right. Let's go back to the default application, and I have my about thing here that is also that page that I have shared. So now I have an application sharing the same code between my web application and my mobile applications. So if I change a component, for example, I say, oh, I want to have, and that's what I did recently, the control to open a door at people's home. I changed that control. I had to change it in one location. I had, of course, to build and compile and have different release pipelines in our GitHub. But that's the way you can easily release things that are being shared. All right. So this was the .NET MAUI application. And the last part of this talk is something that I want to focus on is, of course, testing. We all hate testing, I assume, but we all realize that testing is quite important. And for this was not, this was also quite new for me. So I was used to unit tests. I was used to building integration tests. And for that, we use SpecFlow, where you can describe your tests in somewhat of a functional language. And for every step, you link to some code that you execute, so test steps actually. So that was quite important, and we also focus mostly on those. Right? So these tests are being executed automatically in the release pipeline. But what I also found is that since you have so many different orientations and possibilities and screen sizes, it's not always easy to have an idea on how is this being rendered there, and is that layout being working the way it should. And for that, we said, okay, we need to have some front-end tests as well. We want to make sure that, for example, we had a wizard to onboard customers, like an 8-step wizard, where they had to click, they had to sign in, they had to give credentials, they had to select different things and so on. And that wizard is quite important because it's the first impression they get from our application. And that we said, okay, let's build a front-end test that we can just click a button and we see the whole navigation of that wizard being done instead of myself pressing F5, clicking, entering details every single time again, because that takes too much time. And if it takes too much time, you stop doing it. So we said we want to automate, and we started looking at different items, and we ended up with Cypress.io. And that's what I want to show right now. So this is how it typically works. You have different steps. You can say, okay, this is, for example, the sample on their website where you have a to-do application, and you can just download it and work there instead of building your own application. But there they say, okay, we visit this application, then we get this new to-do, tuck, tuck, tuck. We enter, buy some cheese. If that works, then we should find a label that has this and this. So that's the way you can build your tests, and you can then easily execute it. But what's better than looking at a screenshot? That's of course looking at a live demo. So that's what I want to do as the last demo of this talk, is showing how I had that picture album built. How can I test it? And that's what we will show here. So to install Cypress, you have to have npm and node on your laptop, but that's quite fast. It's like one-step installation. If you have that, then you can say something like install npm get Cypress or something, but it's fully documented. And once Cypress is installed on your laptop, you can actually make it part of your specific application. And let's see here. Oh, I'm not finding it, but there is a page. Let's go. to open a Finder, which is the Explorer. So I have here front-end testing, and if I create a new set of tests, you can see that there are some files being created, and this is actually the spec file where all my tests are being part of. Right? If I, of course, want to open it in a nice layout, then I can say, okay, npx Cypress open. So I'm opening it here, and then the Cypress client opens, and you can see it has found end-to-end tests. So you have the end-to-end tests, which is the only ones that I have used. You also can build components that you can test specifically, and that's another set of tests, right? So you can do that. So I'm here saying, okay, let's dive into the end-to-end tests. If you have different browsers installed on your laptop, you can specify which browser you want to use for these tests. So that's also interesting. You can use Chrome and to see how it renders there. But I have Edge here, so let's start testing in Edge. And now it actually opens my test. So this file that I have shown is there specifically added here. And if I click it, you can see it starts executing the specific tests. So for example, here I have visit this application, and you can see the different steps here, right? You can see how it behaves. Can show pictures, for example, as a test that I have added. So let's visit localhost pics of pizza, and then you can see how it typically works. And you can say, okay, I want to find an ID, a component that has ID equals picture, and it should have a length of 8, for example. So I should have 8 pictures listed on my application that have this ID, and so on. Here I'm getting another location. I'm going to the About page, and I want to make sure that it has that specific button or that specific image source in that image. So these are types of tests that you can do. But if you navigate back here and you see these things, I can imagine that some of you say, well, this is syntax and so on that we are not really familiar with. It's not that easy, and so on. What you can do, and that's quite interesting, if you run in what we call the experimental mode, you can specify and you can have, like, you can record some actions that you can just, you can record some actions, and that will translate in tests. And that's what I want to do here. But something that I wanted to show here is that you can have all these different screenshots of every step that happens. All these screenshots are being saved. So if afterwards you want to say, oh, I have a customer that was complaining about layout on Chrome on his iPad, well, you can have this test. You can look at your test of that build. You can navigate to that specific browser and so on, and you can find the screenshot if you have included it in your tests. And then you can also immediately see it without having to start your application and things like that. So I think that's quite interesting for those type of tests. These type of tests should never have a replacement for your unit or integration tests. This is just an extra thing that I found very powerful and interesting for that. Now, what I said is, maybe I want to have a new test that I want to record, and that's what you can do here with that magical wand. I can say, okay, I will add a new test, and then you have to enter the URL. Let's click continue. And here I can say, oh, every time I click increase, I will click it 3 times. I will do a decrease, I will do an increase, and I will do a reset. These are all actions that I have done. Then I can specify, let's save the commands there. What's the, let's call it netconf name of the test. And if I go here to my application, you can see that there has been a new test defined, created by Cypress Studio, which with the name of netconf. And what you can see, automatically all the actions that I did are being translated in, let's say, some actions. And then I can, of course, say, this should have text of this and that at the right locations. So that's quite interesting because otherwise it's too cumbersome. What I also want to give as an important takeaway, let's search for increase. If I go back to my application here, I think it's in my page, or is it here? So the counter application, every demo of Blazor has to have a counter. What you can see is I have this button, which is just the button of NET Blazor, and it has an ID. It has an ID of with the name increase and decrease. So that's just an attribute that I have added, which is helping me in finding. Oops, let's go back to in finding that component. So if I'm not doing that, then it has to search the whole navigation document tree, and it will say, oh, I want to get that button in that specific location that is part of the table and the body and so on. But if later on I change my layout, then my test will break. And here I'm specifying that I'm just clicking on a button with that specific name, increase. So that's the tip I want to give. That you have to specify these IDs on the components that you want to have part of your tests. For example, the text where my counter value is, I gave it the name of counter. And again, that makes getting the value of that counter easy, just like that, instead of having to navigate everything there. Okay. What I did not include in my demo here is making Cypress part of the whole release pipeline, but that is possible, and it's also well documented on that application. All right. And with that, right on time, I want to thank you. My Twitter or X handle is there, and also my GitHub thing, and the source of this demo can also be found on github.com/Sam Vanhoutte. I see that there's one question of Gopal. When you ship a Blazor hybrid application with MAUI for Windows, is there a dependency on Edge browser or WebView runtime on the client's machine? And I actually have to say, I don't know. So I'm not on the Windows platform, and I have no idea on how it works locally. But for .NET Blazor server, yeah, you can use whatever browser you want. So I'm not 100% sure how that works, because the last thing I want to say, I'm not an expert in these things. I wanted to share how I have made myself, let's say, in the shortest possible time, how I made myself from a backend person to a full stack person. But that means that I also still have to learn and search a lot of things. So sorry for not being able to answer those questions straight away. Any questions, any feedback? If not here, you can always get me through Twitter, and otherwise, thanks for your attention and have a good day.